Have you ever wanted to build a real-world application? I mean, truly from the ground up? Well, today, that is exactly what we are going to do. We're going to design a full-stack issue tracker. Think something like Jira or Trello, starting with nothing but a blank slate. So, let's get into it.
So if you've ever used a tool like Trello or Jira and just had that little thought in the back of your head, how does this actually work, under the hood? Then you are in the right place. Today, we're going to pull back that curtain and create the complete architectural blueprint for our very own version.
All right, before we start laying any bricks, let's just make sure we're on the same page. When we say full stack, what we mean is the entire application. We're talking about everything the user sees and clicks on, that's the front end, and all that powerful machinery chugging along behind the scenes, the servers, the logic, the database, that's the back end. And we're designing the whole shebang from start to finish.
So here's our game plan, our blueprint for this whole explainer. We're going to start with the big idea, the concept. Then we'll lay the data foundation, build the API bridge that connects everything, design the user interface, add our security fortifications, and then, at the very end, we'll step back and look at the final blueprint.
Okay, first things first, what are we actually building? And just as important, who are we building it for? Defining this scope is probably the most critical first step of any project.
So, here's our scenario. We're building an internal issue tracker. Now, that word internal, that's the key. It immediately tells us a whole bunch of things. For one, we don't need to worry about public access or Google finding us. Nope, our users are employees, and their goal is super simple: manage tasks. That single decision, to make it an internal tool, really sharpens our focus. We're aiming for simple, secure, and reliable above all else.
All right, time to build the foundation. And I mean this literally. Just like a skyscraper needs a rock-solid base to stand on, every great application is built on a really well-designed data structure. And that all starts with the database.
So, what are the essential pieces of our system? The easiest way to think about this is to think in nouns. We have users, right? The people actually doing the work. We've got projects to keep all that work organized. Then you have the issues themselves, the tasks. And finally, comments, which is how people talk about the issues. These four things, they are the absolute core of our entire application.
And this is where the magic really starts to happen. We take those abstract ideas and we turn them into a concrete database table. So here's a peek at our issues table. Yeah, sure, it has the obvious stuff like a title and a status. But the real power, the secret sauce, is in these fields right here: project ID, reporter ID, and assignee ID. See, these are the invisible threads that connect everything, linking an issue to its project and to its people. This is the heart and soul of a relational database. It's all about those connections.
Okay, our data foundation is in place. But now we need a way for our beautiful front end to actually talk to it. And that is the job of the API. You can think of it as the bridge, the messenger, or maybe even the plumbing that connects everything together.
Now, to build a good bridge, a reliable one, we follow a design pattern called REST. It's really just a set of simple, common-sense rules. We name our URLs based on what they are, so nouns, like /issues. We use universal actions, or verbs, like get to read data and post to create new data. And we make sure everyone is speaking the same language, which is JSON. So why bother with all this? Consistency. It means any developer can look at our API and understand how it works almost instantly. It just makes life easier for everyone.
And here's what that looks like in the real world. Every single action a user can take in the app maps directly to one of these API endpoints. You want to see all the issues? The front end just calls get/issues. You need to change who an issue is assigned to. It just sends a patch request to /issues/your-ID with the new info. It's this super clear, predictable mapping that makes the whole system just work.
Okay, we have our foundation, we have our bridge. Now it's time to build the facade. The part of the building that everyone actually sees and uses, the user interface.
Modern web development isn't about building giant, clunky pages anymore. It's about building with components. Think of them like Lego bricks. We have bigger components that act as pages, and inside those pages we put together smaller, reusable pieces like a filter bar, or a comment form, or even a simple little button. This approach keeps our code super organized and way more efficient.
Now here's a real pro-level move. We split those components into two types: smart and dumb. The smart ones are the brains of the operation. They're the ones talking to the API and managing all the data. The dumb ones? They just care about the look.
They just take data and make it look pretty. This separation is an absolute game changer. It makes our code incredibly easy to debug, test, and reuse down the road.
Our application is really taking shape, but it is not done yet, not by a long shot. We need to build the fortifications, the locks on the doors, the security guards, the safety checks, all the stuff that protects our data and our users.
First up, we have to figure out who's allowed in. That's authentication. The process is pretty simple. You log in and the server gives you a special digital key called a token. From then on, every time you make a request, you show that token. But just getting in the door isn't enough. We also need authorization, which answers the question, okay, you're in, but what are you actually allowed to do? An admin can do way more than a regular member, and this layer is what enforces those rules.
Another critical fortification is validation, and we do it in two places. On the client side, in the browser, it's all about good user experience. Giving that instant feedback like, hey, this field is required. It's helpful. But on the server side, it is all about security. The server rechecks absolutely everything, because it is the final, absolute source of truth.
And look, if you remember only one thing about security from this, please let it be this. What happens in the browser is a friendly suggestion. It's a convenience. What happens on the server is the absolute law. You can never, ever blindly trust data that comes from the client because it can always be faked.
So, we've built the structure and we fortified it. Now it's time for the final piece of our blueprint. This is a really crucial decision about how our application is actually delivered to the user's browser. And the choice comes down to these two. Server-side rendering, or SSR, where the server does the work of building the HTML page, and client-side rendering, or CSR, where the browser just gets a bunch of JavaScript and builds the page itself. SSR is awesome for public websites that need to show up in Google. CSR is fantastic for those rich, interactive dashboards that feel more like a desktop app. So, let's think, given everything we know about our project, that it's internal, it needs to be secure, it's a dashboard-style app, which one of these really makes the most sense for us?
Well, the clear winner here is client-side rendering. We couldn't care less about search engines, but we care deeply about creating a fast, fluid, app-like experience for our users. For a dashboard like this one, CSR is a perfect fit.
And there it is, our complete blueprint. We started with a solid relational database, we built a clean, predictable RESTful API on top of it, we designed a modern, component-based front end, we locked it down with tokens and tough validation, and we chose client-side rendering for a fantastic user experience, from the database all the way to the dashboard.
And that is how you design a full-stack application. We've gone from just a simple idea to a complete, robust architectural plan, and we made intentional choices every single step of the way. And this isn't just a blueprint for an issue tracker. This is a template for building almost any modern web app you can think of. So the only real question left is, what are you going to build?